We want to solve that. That is my 4. Okay, let me say that where I can reduce this. Right? Right. So the first thing that we need to form here is that which is called an auxiliary equation. Remember, your auxiliary equation is your M equation. So your M equation here will be your M squared. In other words, your second derivative is replaced by M squared plus what? Plus 4. Your first derivative by M. And the next one is plus what? Plus 4 will always give us 0. Remember where we started. So we've got M squared plus 4M plus 4 equal to 0. Then we solve that. Factors there are M plus 2 into M plus 2 equal to 0. That is M is equals to minus 2. But you can see that there are 2M plus 2. So we say it is twice repeated. So type of roots here, roots equal and repeated. Remember what I said? We said if the roots are equal and repeated, we have YCF is equals to AE to the power minus 2x plus, because it's repeated, then B small x there, A to the power minus 2x. That will be the solution that will come out of that, because the roots are real and repeated. Now, next is to solve for y. From the given equation, make y the subject of the formula. You will see that y is going to be 1 all over, to take y as a common factor after grouping there, we'll get d squared plus 4d plus what? Plus 4. The action is on 1. The action is on e minus 3x. Now think of the theorems. Theorem, which one to use here? Theorem 2, theorem 1. So by theorem 1, then we have y pi is equals to theorem 1, this must come in front, a to the power minus 3x times 1 all over what? 3, d is replaced by minus 3, so it's minus 3 what squared plus 4 times minus 3 plus what? Plus 4. Action is on e, sorry, we're left with 1 now because exponential is already in front. That gives us a to the power minus 3x, 1 all over, what are we going to get there? That's 9, that's minus 12, minus 12, that's minus 12 plus 4. This will give us a to the power minus 3x, 1 over what? What is that? It's minus 12, that is 13, that's minus 1. So the answer becomes what? The answer becomes, so that is 13, no, it's positive 1 in fact, because it's 13 minus 12. So the answer is e to the power minus 3x. Then your solution is the combination of the two. So our solution is y is equals to YCF, the one that you obtained earlier on, plus what? Plus YPI, which gives us our YCF was a to the power minus 2x plus bx e to the power minus 2x, then plus pi, which is just a to the power minus 3x. If you like, you can write that as what? If you can take a common factor here first to a to the power minus 2x common, then you've got a plus bx. If I group these two, then you leave the other one as a to the power minus 3x. That is then a solution. So that is our solution. How to solve a differential equation using operator D, we form an auxiliary equation as our starting point. That is how we work it out. Right, let us look at a much more challenging one. Look at the following. It's right in your guide that I gave you in case you do have with you right now. This one says 2 d squared y plus 7 dy plus 12y is equal to 5e to the power 2x. What are we given? Given that y of naught is 7 over 6 and what? And y prime of 0 is minus 5 over 3. That is what we are given. But our starting point, this is a differential equation. That is our differential equation. We need to solve it first, right? Before we apply, these are called the conditions that we are given. So our starting point, we form the Ox equation. The auxiliary equation is our key equation. We form the Ox equation. Ox equation. Our Ox equation is m squared plus 7m plus 12 equals to 0. Then solve that. It's quadratic in m, factors of that. M plus what? Plus 3 into m plus 4 equals to 0. Then what is m? Therefore, m is minus 3, or otherwise, m is minus 4. What type of roots are these? The roots are real but not equal. Therefore, what is YCF? YCF is a to the power minus 3x plus what? Plus b a to the power minus 4x. That is our YCF. Now, try and form then your YPI. Your YPI is whereby you bring down this whole equation now and you make y the subject of the form. Let me have it down. Then we have d squared y plus 7 dy plus 12y equal to 5e to the power 2x. If I were to group here y is common, take y as a common factor, then here you're left with d squared plus 7d plus what? Plus 12 equal to 5e to the power 2x. Make y the subject of the formula. Therefore, the y is going to be divided by the whole lot. That is 1, I can write it in this fashion, 1 over d squared plus 7d plus 12. The action is on 5e to the power 2x. That is how I solve my y. But this y I am solving is given a special name. It's called a YPI. It's called a particular integral. This is called YPI. That is what I'm going to find there. Now, the moment I have this, then I think of all the theorems that I've done with respect to operator t. There is the exponential here. Again, I'll use theorem 1. By Tm1, by theorem 1. So my YPI is going to be e to the power 2x in front. Don't forget. 1 all over. There is d, which is replaced by 2. That is what? 2 squared plus 7 times 2 plus what? Plus 12. And I'm left with a 5 there. That gives me, I'm using theorem 1. That's e to the power 2x times 1 all over. Let me work that one. This is going to be 4. This one is going to be what? 4 plus 14. That is 18. That becomes 30. And the action here is on 5. But this becomes 5 over 30. That is 5 over 30. That is what? 1 over 6. So the answer here is what? It's e to the power 2x over what? Over 6. Therefore, the solution will be y, big Y is YCF plus YPI. That gives us your y. Our YCF was e minus 3x plus b e minus 4x plus what? Plus a to the power 2x over what? Over 6. That is the solution. But now we were given what we were given earlier on. What is it that we were given? if I can take you back. We're given that y of naught is 7 over 6, and y prime of naught is minus 5 over 3. Oh, we note that. Call that y of naught. Y of naught is what? It's 7 over 6. This means y is equals to 7 over 6 when x is 0. That is the meaning of that writing there. So y of naught is equal to 7 over 6. Means y is 7 over 6 when x is 0. Now, what are we given there? We go back. Let me label that equation as 1. We go back to 1. Therefore, from 1, we use what we are given. What are we given? There is my y, which is now 7 over 6. Therefore, 7 over 6 is equals to a to the power minus 3x is 0 plus what? Plus b a minus 4x is 0 plus what? A to the power 2 of naught over what? Over 6. You can see this becomes what? A plus what? Because this becomes 1a plus b plus what? Plus 1 over 6. Mind you, everything is equal to over 7 over 6. Transpose, that is 7 over 6 minus 1 over 6 is equals to a plus b. This is 6 over 6, which is just 1. Therefore, what? 1 is a plus b. I call this one is equation 2. Okay? Now, equation 2 comes from what? Y is 7 over 6 when x is 0. But we're also given we were given what? The derivative. What is happening now? Oh, sorry for that. Also, we are given y, the derivative of that. We are given y prime of 0 is equals to minus 5 over what? Over 3. Which means what? That is, this means dy over dx is equal to minus 5 over what? Over 3. It means y dy dx is equal to 0 when x is not, which means that dy over dx is minus 5 over 3 when x is 0. Now we don't have the derivative. We need to differentiate that, the general solution. Where is our general solution? There is our general solution up there. So we find the derivative of our solution. Therefore, dy over dx is equals to differentiate that. It's going to be minus 3a e minus 3x. Next one, it's minus 4b e minus 4x. Derivative of e to the power 2x is 2e to the power 2x over 6. That on its own would become what? E to the power 2x over what? Over 3. What is it that we know? What is it that we know? We know that dy dx is what? It's minus 5 over 3 when x is 0. Therefore, minus 5 over 3 as it is given is equals to minus 3a e to the power minus 3 of 0 x is 0 minus 4b e minus 4 of 0 plus what? Plus e to the power 2 of naught over 3. That would be minus 5 over 3 equals to, that is minus 3a, that will be 1, minus 4b plus what? Plus 1 over 3. Solve. So solve for a and b. you realize that if I transpose this, it will be minus 5 over 3 minus 1 over 3 is minus 3a minus what? Minus 4b. Therefore, what is that? This is minus 6 over 3, which is minus 2. This whole thing is minus 3a minus 4b. I call this one is equation 2. But in equation 1, I can make 1 the subject of the formula. So in my equation 3, in my equation 2, this is supposed to be equation 3. So in equation 2, 1a can be 1 minus b. You can substitute that. Therefore, from 1, a is what? It's 1 minus b. Therefore, I substitute that. Minus 2, it's minus 3, a, 1 minus b, minus what? Minus 4b. That gives me minus 3 plus 3b minus 4b, that is minus 2. The total is, I'll get 1 is equal to what? Minus b. Therefore, my b is what? My b is minus 1. Check whether I've done that correctly. Yes. No. Yes. So b is minus 1. What is a? B is minus 1. A is what? A is 2. So my a is 2 if b is minus 1. Then I go back to my solution. Therefore, my solution now, finally, my solution is y is equals to, I think we had a to the power minus 3x plus 4 plus what? B, what? Sorry. Okay, even if I can write it like that, minus 4x plus what? A to the power 2x over 6. But my a and b are known, so that becomes a, it's 2a minus 3x, and b is what? It's minus 1 minus a minus 4x plus what? Plus a to the power 2x over what? Over 6. And this is your final answer. And that is your final answer. Are you okay there, good people? Are you okay? Oh, okay. Let me have another one. We try this one, number 3. So it's d squared to d squared plus 4 y is equals to 2x plus 8. We solve using operator D. Now, first thing, Ox equation. Form an Ox equation. Ox equation is the M equation. Remember, there is d squared, is m squared now into what? Into m squared plus 4 equals to 0. That is the Ox equation, auxiliary equation. Solve for m. Therefore, m squared is equal to 0, or m squared plus 4 is equal to 0. Therefore, what is m here? That is m is equal to 0 twice. You can see it's repeated there. Or m squared is what? It's minus 4. No, so m squared is minus 4. So take the square root of m here. You'll see that the roots become imaginary now. So it's plus minus what? The square root of minus 4, which is equal to plus minus, we have seen that will be what? 2j. Solution here for m equal to 0 twice. So your y is going to be a to the power 0 of x. That's because it's repeated, b x 0 of x, because your m is, but the root is repeated here. Or what here? Here the roots are imaginary or complex. Certain zata y, au bani, au e, alpha, x, into, I've already used A there. I'll say here C, what? Cos beta of X plus what? Plus D, skip D. Let's say we use E, what? Sine beta of X. Then do the substitution. What is my alpha here? Remember, my Z can be written in this form, alpha plus beta J. But my alpha here is 0. So that would be e to the power 0 of X into C, what? Cos beta. My beta is 2X plus A, what? Sine 2X. This will be 1. So if I combine these two, that one, this one, together with that one, I combine them, they will form just YPS, YCF. So YCF coming out of the 2 will be, that will be A plus what? Plus BX. That will be 1. That is 1 there. Sorry, here it's supposed to be BE. There's A missing here. Sorry, let me write it like B e to the power 0. So there is X. What am I doing now? Sorry, I'll squeeze it here. Y is A is 0X plus BX is 0X. So if I work that thing out here, it's A plus BX plus what? Plus that one will be 0. C cos 2X plus A what? Sine 2X. Please bear with me now. But this is the YCF first part of it. Right? Now we must solve for what? For Y. What was the original equation? Original equation, remember, was d squared plus 4 of Y equals to what? It was equals to 2X plus 8. We must solve for Y here. It's straightforward. Already Y is taken out. So make Y the subject of the formula. Y is 1 all over d squared into d squared plus what? Plus 4. Acting on what? Acting on 2X plus what? Plus 8. And we have seen something like this before when we're handling operator D, general. There is 1 over d squared. 1 over d squared, it's known. 1 over d, it's known. It's integrate. If it means we twice integrate that. So we'll keep this 1 over d squared out. Our concern is on this d squared plus 4. This d squared plus 4. And here, there's no theorem that you can use here. 2x plus 8. We can't use theorem 1, 2, or 3. So we are going to expand here, is it? But before we expand, let us see whether we can manipulate this d squared plus 4 so that it look like 1 plus d to the power minus 1 or something else. That can be rewritten as 1 over d squared, I leave it out. 1 over, if I take d as a common factor, 4 as a common factor there, I will have 1 plus d squared over 4. On what? On 2x plus 8. That becomes 1 over d squared. And I've pulled out what? 4 is a common factor. Sorry, I must have a 4 outside here if I take it out. So 1 over 4. Then that will sit on top as what? As 1 plus d squared over 4. Index minus 1. Then on what? On 2x plus 8. That becomes, that's 1 over 4d squared. And what are the terms that comes out of that? 1 plus d, just think of it as 1 plus d to the power minus 1, whose terms are 1 minus d, njalo. So the expansion, the terms here are 1 minus. Then the second one is going to be d squared over 4 to the power 1 as being d, because this d is already d squared. But now, in as far as this is concerned, I'm supposed to stop here because this is already squared now. I can't go higher than that. Then I have 2x plus 8. If this 2x was 2x cubed, then I was going to move up to d cubed. So that gives us 1 over 4d squared into 1 times the whole lot is the whole lot, 2x minus 8. Now, d squared over there, d squared means take the second derivative of that. Everything will be 0 on that side. Becomes 0 because I will be differentiating it twice. So I don't have index 2 there. That is why I've got 0. So work it out, 1 over d squared. Then push a 4 inside there. 2 over 4, what is that? That is x over 2. Then 8 over 4, that is what? That is minus 2, if I'm not mistaken. That is that. Am I right there? Yes, that's x. Then next, integrate. When you integrate that, what are you going to get? What is the integral of x over 2 for the first time? So in other words, 1 over d, integrate for the first time is going to be x squared over 4 minus what? Minus 2x. That's the first time. Once more, integrate that. It's going to be x cubed over what? Over 12 plus what? Minus. Integrate this for the second time. I think it's going to be minus what? Minus x squared. I hope we are still okay there. Then finally, what is the answer? Answer will be, finally, your answer is y is given by y CF plus y PI. Let's go back. What was my YCF? My YCF was that one on top, which is A plus BX plus C cos 2x plus D plus E, what? Sine 2x plus what? Plus x cubed over 12 minus x squared. That is your solution. Okay. That is your solution. Right. Are we still there? A slight mistake here. It's plus here, not minus. Because it was from this multiplying the whole lot. The other one is for 0. Are you okay there? Next. Let's try this one. Example number 4. D squared y plus 9y is equals to 3 cos 3x. Again, we form our Ox equation. Our Ox equation is what? Is the M equation. Auxiliary equation. It is M squared plus 9 is equal to 0. That is our auxiliary equation. Good people, are you still around? Okay. So M squared plus 9 equal to 0 is our auxiliary equation. Solve for M here. That is our M squared is minus 9. You can see taking the square root there will make that one undefined. Therefore, M is what? It's plus minus the square root of minus 9. Now, complex numbers, we can force that to be real. So it's plus minus 9j squared, whose square root is what? Is 3j. Now, from here, if the roots are complex, what is the solution? Remember, note where complex numbers, if that is a complex number as a solution, your y is given by y, it's a to the power alpha x plus what? A, what? Cos beta of x plus what? Plus b, what? Sine beta of x. That equals 2. Now we do. Now my alpha here is 0, so it's a to the power 0x, a, what? Cos 3x plus b, what? Sine what? 3x, which in actual fact gives us YCF, can be written as just A, what? Cos 3x plus B, what? Sine 3x. That's my YCF. In most cases, you'll get that 3 marks. Right? Next, we solve. We go back to the given differential equation. There is dy squared, there is 9y. You write it as it is. That is d squared y plus 9y equals to 3 cos 3x. You take y as a common factor here. Take y as a common factor. Then y into d squared plus 9 is equal to what? Is equal to 3 cos 3x. Solve for y. Your y divide by that, right? It is just d squared plus 9 acting on 3 what? Cos 3x. Now, think of your theorem. What do we call this y there? We call it ypi now, particular integral. Now, think of the theorem. Theorem what here to use? Theorem 3. Why? Because there is a trig function here, cos, there is d squared there. Remember what it says. This 3 will be replacing minus d squared there. Therefore, ypi is what? It's 1 all over minus what? 3. Remember how you replace that? D squared plus 9 on what? On 3 cos 3x. As you can see here, this is minus 9 plus 9. Therefore, theorem 3 fails. Theorem 3 fails. I hope you'll recall that. If theorem 3 fails, what do? We make use of complex numbers and then apply theorem 2. Perhaps let me write that down. Theorem 3 fails, then use complex numbers and what? And theorem 2. Because theorem 3 is failing. Therefore, your ypi is equal to 1 over d squared plus 9 acting on 3 complex numbers. How do you define that? Is a to the power 3jx. This 3 is that 3 there of x. Since we know that by definition, we said a to the power j of theta is what? Is cos theta plus j sine theta. Remember that. That is by definition. Now, but now, this e to the power 3j theta contains the whole lot. Yet we're just given here what? The cosine function. So we must be specific. So the one that is real is cos here. So we say we are taking the real part of it. And then we apply theorem 2 at the same time. That is e to the power what? 3jx. If you apply theorem 2, 1 all over. There is d, which is now going to be d plus what? 3j all squared by theorem 2, plus 9, acting what are we left here? We are left with a 3. I hope we are clear there. Next, real, we stand for the real, we take the real part. 3jx, 1 all over, we work this thing out. It's going to be d squared plus 6dj, 3j squared. 3j squared will be minus 9. Minus 9 and 9 is 0. So the other 9 cancelled, then we're left with a 3 here. All right, let's move on. That becomes, so my ypi equals to real a to the power 3jx times 1 over. I take out the common factor d because 1 over d is known. Then I'm left with d plus 6j on what? On 3. Now next, now this is a constant. One of the cases, apply case 1. Apply case 1. That is, if this is a constant, you introduce e to the power 0x. So e to the power 0x comes in. Then theorem 2, theorem 1, sorry. So it's RA 3JX 1 over D. Then D now is replaced by that naught there. Naught plus 6J on what? On 3 there. That gives me RA 3JX 1 over D. Then this will be 3 over 6. 3 over 6 is half. That's 1 over 2J. That will be left after I've simplified that. Now rationalize the denominator. 1 over J. You recall I said can be written as what? Is minus J. So it's RA 3JX 1 over D into minus J over 2. Because 1 over J is 1 over J times J over J. This is J times J squared, which is just minus J. And in 1 over D means what? Integrate. So it's R E 3JX times minus JX over 2. Last but one step. Now bring back that. What is the meaning of that? Recall that e to the power 3j will have r. Now, back its definition. It stands for cos 3x plus what? Plus j sine 3x. This whole thing is represented by that whole thing there. Times, further multiplied by minus jx over 2. That gives us. Now, let us multiply by this. So minus jx times that is going to be r minus, it's going to be r minus jx over 2, what? Cos 3x. Minus j times this j is negative j squared. But j squared itself is minus 1. So it's minus minus. So it becomes what? Plus what? X what? Sine 3x over what? Over 2. But now the r outside says you take the imaginary. I mean, you take the real part. This is a complex number, good people. The complex number consists of two parts. One, it's a real part, and the other, it's an imaginary part. How do you see if this one is imaginary or a real part? The one which j as a coefficient is imaginary. The one without j is what? It's a real part. If you look at these two, the one without j is the real one. Therefore, your answer here, as indicated by r, is minus x what? Sine 3x all over what? All over 2. That's your YPI. Right? Finally, what is your solution? Your solution will be, therefore, general solution will be y is equals to. Y is equals to, what is that solution? Remember, YCF is A cos 3x plus B what? Sine 3x plus 1 over 2 of x what? Sine 3x. So it's not minus here, it's plus. It's plus. And this is your final answer. And this is your final answer. Are we okay so far?
Yes, sir.
Okay. Let's try another one involving a trig function again, so that we'll get used to it. Then number 5, d squared y plus 4y is 8 sine 2x. Right, form an Ox equation. Ox equation. Ox equation is what? It's m squared plus what? Plus 4 equal to 0. Solve for m. We have seen that. That is m squared is what? It's minus 4. Solve for m. That is m is plus minus 2j. I think we have seen that. Right? Therefore, what is that YCF? YCF is alpha, it's not there. So it's going to be A I skip the e to the power 0x there. A, what? Sine cos, what? 2x plus what? Plus B, what? Sine 2x. That is your 3 marks. In case where you are not writing a multiple choice question. Right. Then your particular integral. Particular integral, you write that equation as it is and make y the subject of the formula. Therefore, y there, without any loss of time, is d squared plus what? Plus 4 is equal to 8 what? Sine 2x. Solve for y. Therefore, your y is equals to 1 all over what? D squared plus 4 acting on 8 what? Sine what? Sine 2x. This gives us. This takes us straight to theorem 3 without any doubt. Why theorem 3? It's a trig function. There is d squared. By theorem 3, which I think is going to fail. So 1 over there is 2. So it's minus 2 squared plus 4 acting on 8 what? Sine what? 2x. Then minus 4 plus 4 is 0. Then you write that theorem 3 what? Fails. Then you'll use theorem complex numbers, then apply theorem 2. Exact parallel. Then by complex numbers, perhaps by complex numbers and what? And theorem 2. This becomes ypi is equals to. Now, now it's going to be 1 all over d squared plus 4 acting on 8e. That 2 now becomes 2j of x. But now, because there was sign here, sign falls under the imaginary. So it's im. Now we are specific now. Im 1 over, and then apply theorem 2. D is replaced by that. It's going to be d plus 2j all what? All squared plus what? Plus 4. Acting on what? Acting on 8. Right, let's work it out. That is I am 1 all over. D squared, that's D squared, the same story as before. D squared plus what? Plus 4dj. That will come out from there. Then I'll get here 2j squared, which will be minus 4. Minus 4 and 4, that will be 0. Then I'll be left with 8 here. Right? Now you know the story now. D squared and that, there's a common factor there. I am, so 1 over d is common. And then I'm left with what here? With d plus what? With d plus what? Plus 4j. And 8 up there. Now, I won't penalize you, good people, if you don't keep on indicating that the next thing that you'll use is that. If I will realize that we have substituted that. So that is case 1. That is, I am 1 over d by case 1. Then you are left with 1 over 4j. Then acting on what? On 8. I will understand that because d was replaced by that note there. That is case 1. That equals to, again, I am 1 over d over what? This is 8 over 4j, which is nothing else but what? It's 2j, which is going to be minus 2j. I've rationalized at the same time. This is 8 over 4j, right? 8 over 4 is what? It's 2. Now, and I'm left with 1 over j. If I rationalize 1 over j, I'm getting minus j. I've done 2 things in one step. So that is I am 1 over d, means integrate that. That is what? Minus 2xj or jx, if I integrate that. There's something that I missed here. Can you tell me? I did not have the exponent here. A to the power 2jx. A to the power 2jx. A to the power 2jx. Now, bring it back. So I am e to the power 2jx as before. Is cos 2x plus what? J sine 2x multiplied by that, which is minus 2xj. Right? Lastly is when we multiply im, this times that, it's minus 2xj, what? Cos 2x. If I multiply this with that. Multiply this and that, there is j times j squared, and the negative is going to be plus, what? Without j now, 2x, what? Sine 2x. So this tells us inside here, I must take what is imaginary. Now this one here is real, this one is imaginary. Therefore, my final answer here is 2x, what? Sine 2x. This is your answer. Finally, general solution will be y is equal to y is equals to a cos 2x plus b sine 2x plus 2x what? Plus 2x what? Sine what? Sine 2x. That is all what we are expected to know. Sorry. Wait, good people. I took the wrong one. I hope you can see. The imaginary here is cos. Sorry. This is imaginary, sorry. This is real. So my imaginary is minus 2x, what? Cos 2x. Bear with me, please. And that one here, it's minus what? 2x cos 2x. That is your final answer. I will give another one again. I hope we are still okay there. I'm under medication, good people, and they are tracking me, but I'll try by all means to finish up. Let me have at least the last one. Number 5, if I'm not mistaken. It's d squared y minus 3 dy plus 2y equals to minus 4e x sine of x, given that y of 0 is what? It's 2, and dy of 0 is 0. Right. It appears as a long one. It's quite long, but it's doable. So note that. Oh, first of all, let us form the Ox equation. Ox equation is the M equation. It's m squared minus 3m plus 2 is equal to 0. M minus 1 as factors to m minus 2 equal to 0. That is, you can find your YCF here. Therefore, your YCF here is what? The roots are real, but not the same. It's a to the power x plus what? b e to the power 2x. Again, that is your 3 marks. Now, next, you want to solve your y, your YPI. Note that definition. Note something that perhaps you don't know. Sine of x is defined as a to the power x minus a to the power minus x over 2. Therefore, we'll have here d squared y minus 3 dy plus 2y equal to minus 4e x into e to the power x minus that minus x all over 2. Which when you simplify, it gives us what? It gives us, can write it as minus 2e to the power 2x. If I multiply at the same time, that and that will cancel, plus what? 2, if I'm not mistaken. I'm multiplying everything inside here. I'll get e to the power 2x, that is e to the power x, minus 4 over 2, that's minus 2. And again, there it's plus, this and that will cancel, minus 2 minus 4 over 2 is 2. So that is my d squared y minus 3dy plus what? Plus 2y. Now, make y the subject of the formula then. Making y the subject of the formula, we will get y is equals to d squared minus 3d plus 2 equals to what? Minus 2e 2x plus what? Plus 2. And what is y? Therefore, y is equals to 1 all over what? D squared minus 3d plus 2 acting on minus 2 to the power 2x plus 2. A bit of a trick here, you have to be careful. You split this whole thing. This whole thing can be written as 1 over d squared minus 3d plus 2. You treat that as itself, right, as one entity, plus 1 all over d squared minus 3d plus 2. The action is on 2. You split that so that we'll apply the theorems relevantly. That becomes then, so my ypi then will be equals to, here I can use theorem 1 here. There is e to the power 2x. So e to the power 2x is 1 all over what? 2 squared minus 3 times 2 plus what? Plus 2, because d is replaced by 2 of the exponential. Minus 2 here, plus. Now this is a constant here. No theorem to use, but we use one of the cases. So introduce e to the power 0x. So it's 1 over what? 0 squared minus 3 times 0 plus 2. Action on what? On 2. That is by e to the power 0x here. Then equals 2. This is e to the power 2x. Let us work this thing out here. This is e to the power 2x, 1 all over. This is going to be 4 minus 6 plus 2 on minus 2 plus 1. This will be 1 because 0, 0, 0, that will be 1. And what you can see here, the theorem fails here. Theorem 1 failed on this part. Now we will treat that separately. Bearing in mind that we have 1, we put 1 aside. So we say here, so this is minus 6 here. This is minus 6 here. So then we say here, theorem 1 fails. Fails here. Then we apply theorem 2. Yp, I'll keep this one aside now. We'll add it right at the end. By theorem 2, because theorem 1 has failed, e to the power 2x, 1 all over. Back here to d squared. So it's d plus 2 all squared minus 3 into d plus 2 plus what? Plus 2 on minus 2. Don't forget that we still have that one. That gives us e to the power 2x, 1 all over. Work that thing out. It's d squared plus 4d plus 4 minus 3d minus 6 plus 2 plus 1. Don't forget the action here is on minus 2. Next, that becomes e to the power 2x, 1 all over d squared plus 4d minus 3d plus d, and then 4 minus that will be 0. This is 4 minus 6, then that becomes 0. So minus 2 plus what? 1. This is known to us. It's e to the power 2x, 1 over d common factor. Then we're left with d plus 1 here, into minus 2, or into minus 2 plus 1. That becomes, can expand that now, e to the power 2x. No, you are not going to expand, sorry. 1 over d. Now, do you see this minus 2 is a constant? We apply e to the power 0. So that will be minus 2 there, all over what? D now is 0 plus 1 plus what? Plus 1. Why? Because this is a constant now. So that gives us e to the power 2x, 1 over d. What are we left with here? We are left with minus 2 on top, because this is just 1. plus what? 1. Then what is 1 over d on that? Integrate that. A to the power 2x. Integral of minus 2 is what? It's minus 2x plus what? Plus 1. So that's my YPI. So therefore, the general solution is y is equal to YCF. What was YCF? It was A to the power what? E to the power x oh yes, e to the power x, e to the power 2x. Is a to the power x plus b e to the power 2x, and pi, that will be minus 2x e to the power 2x plus 1. That's the general solution. But now the story does not end there. They say what? The derivative, we are given the derivative as well as y of naught is equal to 2. We know that y is equal to 2 when x is equal to 0. Let's use it on this equation here. Let's use it. Use in 1, therefore, in 1. Therefore, y is 2. 2 is equal to a. X is not. When x is not, that will be just 1. Plus what? Plus b. When x is not, this will die everything. Plus 1. Therefore what? Therefore 1 is a plus b. You call that one is your equation 2. Next, use also another condition. dy of naught is naught. What does that mean? Also, dy of naught is equal to naught, which means derivative dx dy is equal to 0 when what? When x is 0. In what? In 1 again. In 1 again. In 1 again, y is what? dy, oh, before that, in 1 again, because they are talking of the derivative here, we differentiate that now. In 1 again, find the derivative. What is the derivative there? dy over dx is equal to, derivative there will be just a e to the power x. Derivative there, don't forget, 2b e to the power 2x. Derivative there, use the product rule, minus 2e to the power 2x, and again minus what? Minus what? Minus 4 what? X e to the power 2x. Derivative of 1 is 0. How did I differentiate? I used the product rule. I started with 2x derivative while keeping that one as a constant. So the derivative of 2x is minus 2e to the power 2x. Then plus, because of a minus, so it's minus. Then differentiate, keep 2x. Derivative of e to the power 2x is 2e to the power 2x. With this 2 in front is minus that. And do the substitution. dy dx is 0. Therefore, 0, which is dy dx as given, is equals to a, still x is 0. It becomes 0. 2b, x is 0, that will be 0. Minus 2, what? Minus 2. X is 0 here, that will be 0. And that is 2 is what? It's a plus what? Plus 2b. I call this one is my equation 3. Then equation 2 and equation 3, you can see in equation 1, in equation 2, you can make a the subject of the formula. A is 1 minus b. A is 1 minus b. Then put it in equation 2. Therefore, 2 is what? There is a, it's 1 minus b plus what? Plus 2b. That gives us what? 1, if I transpose, is what? It's minus b plus 2b is what? It's b. So my b is 1. might B is 1. What is A? Therefore, what is A? A might B is 1. What is A? A is 1 again. A is 1. Therefore, come back to the general solution. What was our solution? When we substitute that this was our equation then we come back now and substitute where A and B are now known. Therefore, solution is y is equal to A is known now, it's a to the power x, B again is known, it's a to the power 2x, and what? And I can't remember the last part of it, minus 2x, minus 2x, minus 2x, e to the power 2x, plus 1, plus 1. If you write this, you can write it as this, plus 1, then you group those two, plus a to the power 2x into 1 minus 2x. This is your solution. Okay. Are you happy there? Are you happy there? I think are you okay there? Right. One last equation. One last one. That will be number 6. It's d squared y plus 2dy plus 2y is equal to 65 e to the power x, what? Sine what? 2x. Our starting point. But what do? We form an Ogh's equation. Auxiliary equation. Ogh's equation is what? It is m squared plus 2m plus 2 is equals to 0. Solve for m. You can say there are no factors here. M squared plus 2m plus 2, no factors there. Use a quadratic formula. M is minus b, it's minus 2, plus minus root of b squared, it's 4, minus 4 times a minus 8. That will be what? All over 2. That gives us minus 2 plus minus the square root of what? Minus 4 over what? Over 2. That is not allowed. It's 2 plus minus 4 is what? Is 2j all over 2 is equal to divide by 2, 1 plus minus 1j. Therefore, what is your YCF? Because the roots are complex, it's a to the power alpha x. My alpha is 1 in this case. So that into a, what? Cos, what? Cos 1x. So cos x plus what? Plus b, what? Sine x. That is your complementary solution. Because here, that one is my alpha, this one is my beta there. My beta coefficient there is 1. Next, your YPI, which is always very important. YPI is where you solve for y. When you solve for y there, you will get what? 1 over d squared plus 2d plus 2 acting on 65 a to the power x, what? Sine 2x. That becomes. Now, yes. Which theorem to use here? Theorem 2. There is exponential and the function. So theorem 2 by theorem 2. Theorem 2, a to the power x, 1 all over. Theorem 2, d is replaced by d plus the index of the coefficient. it's d plus 1 all squared plus 2 d plus 1 plus 2. And we are left with what here? 65. But sine 2x. Next. That becomes e to the power x 1 all over. That will be d squared. Plus what? 2d. Plus what? Plus 1. Plus 2d. Plus 2. Plus 2. Plus 2. On 65. On 65. Please, can you unmute there? I'm hearing that background there. That becomes e to the power x 1 all over. That will be d squared, 2d and that is going to be 4d. Then that and that is going to be plus 5 on what? On 65 what? Sine 2x. Now there is a trig function. There is d squared. Use theorem 3. It's e to the power x 1 all over d squared. It's minus 2 squared plus what? Plus 4d plus 5. We are left here with what? 65 what? Sine 2x. Next. Then we have e to the power x 1 all over. That will be minus 4 plus 4d plus 5. The action is on 65 sine 2x, which gives us e to the power x 1 all over what? 4d. 5 and that will be what? That is plus 1. Action is on 65 sine 2x. Again, rationalize denominator because we still have the trig function, but this d is not d squared. So it's e to the power x. Then what? Rationalizing the denominator will give us 16d squared. Wait, sorry. Not 16d squared on top, but it will be 4d minus 1 all over 16d squared minus 1, acting on 65 sine 2x. Use theorem 3, e to the power x, then 4d minus 1 over 16 times d squared, that will be minus 4 minus 1, because this 2 there is replacing that. So that will be what? 65 what? Sine 2x. That gives us e to the power x 4d minus 1 all over. This is minus 64 minus 1, that is minus 65. And there is 65 up there on sine 2x. 65 and 65 will cancel. No minus e to the power x on 4d. Derivative of sine 2x is what? It's 2 cos 2x times 4 is 8 cos 2x minus what? 1 times that, it's minus what? It's minus sine 2x. Finally, if you clear that out, that becomes what? That becomes minus 8 e x cos 2x plus ax what? Sine 2x. This is your YPI. What is your solution finally? Your y is what? It's your YCF plus your YPI. Your YCF was what? Your YCF was e to the power what? To the power x into a minus cos x plus b sine what? Sine x plus a to the power x, if you like, sine 2x. I'm combining those, taking out a common factor, minus what? 8 what? Cos what? 2x. And this is our answer. And that is your final answer. So far, so good. So far, so good. Is that okay, good people? Yeah, all right, fine. I think I left a minus there. That's -2, so that will be negative. I think, good people, we've exhausted everything now. -1 plus J. Right. And many more problems that we'll keep on solving. Now, this will cover the scope for test 2. The scope for test 1, you'll recall. Let me write that down, please. Scope for test 1. Remember, it is scheduled for the 6th of 11, 2021. That is Monday. I'll give you the venue. 12, sorry. 12. So, linear differential equation, linear DE. Next one will be exact DEs. Next, separation of variables. Separable DEs. And what was the last thing? As well as operator D, whereby, we must know that, how to expand that and evaluate, exclude theorems. So the scope for test 1 will be on linear differential equation, exact differential equation, separable DEs, and then just at the beginning of operator D, how to expand, how to evaluate, how to do this and that. Then the scope for test 2, which I'm planning it to be that other week, I'll tell you the date again. It will be what we have done as from theorem 2, from theorems up until the last section where we are right now. Thank you very much, good people. May I just stop here for today? If there are any changes regarding this, if there are any changes regarding the test, I will tell you, because I think tomorrow I'll be on campus and see whether I do get the venue. Okay, can I stop here now?
Sorry, sir.
Yes.
Ngicela ukhuphe nje uye kwisibali lesi, ngifuna screenshot isibali lesi ugcine ukusenza.
Okay.
Eqaleni.
Right from the beginning. Right. Is that all right?